morning, students. In the applications of the magnetic effect of a current in the subject of physics O levels. So concentrate yourself here. We are going to start. If a piece of the steel is placed inside the wire coil and the current is switched on, the magnetism of the coil and the steel is stronger than that of the coil alone. The current flowing through the coil induces magnetism in the steel. When the current is switched off, the steel keeps some of the magnetism acquired because it is a magnetically hard. So, steel is magnetically hard. It keeps its magnetism. And the second thing is, if a piece of the steel is placed inside the wire coil and the current is switched on, the magnetism of the coil and the steel is stronger than that of the coil alone. So this is these are the points to be remembered. Okay, the second thing is, if a piece of the iron is placed inside the coil, it makes an even stronger magnet when the current is switched on than the steel did. It means the iron makes a stronger magnet as compared to the steel. But when the current is switched off, the iron loses its magnetism completely because it is a magnetically soft. So the point to be remembered is that iron makes stronger magnet as compared to steel, but it is magnetically soft. So that's why it loses its magnetism when the current is switched off, whereas the steel keeps its magnetism because it is a magnetically hard material. Figure A. So here is figure A, shows an electromagnet. Some of the cores of the electromagnets are U-shaped. Figure B. This is figure B. The arrangement has the advantage that the attraction of the both ends can be used simultaneously. Electromagnets are very strong. A small one made in the laboratory. So here is very important point to be remembered. As far as your paper number 1, paper number 2 is concerned, electromagnets are very strong. A small one made in the laboratory from a U-shaped core and a few turns of the wire, each carrying a current of the few amperes like this, is capable of lifting several kilograms. So look at the strength of the magnet. Those used in the industry can lift several tons, for example, car and lorry bodies. Yet, when the current is switched off, the magnetism ceases and the load is released. So this is how magnets are used in the industry. The next thing that we are going to read is the circuit breaker. So here are the applications of this magnetic effect of the current. A circuit breaker is an automatic switch which cuts off the current in a circuit if it rises above the specified value. So every circuit breaker is having a specified value, and if the current goes beyond that specified value, then it is automatically switched. A switch which cuts off. So this is the function of the circuit breaker. This is how the things remain safe in the house. The circuit breaker uses the magnetic effect of the electric current. That is, higher the current, the stronger the magnetic strength to operate. It has the same effect as a fuse, but because fuse was used in the old times and the most modern form of the fuse, the function of the circuit breaker is same as that of fuse, but that is the modern form. But unlike a fuse can be reset, turned on again. So there will be no need to change the wire, as that was the need to operate again the fuse. But in case of the circuit breaker, once it is switched off, it can be turned on again. It can be turned on again very soon after it has turned off. The current flows through two contacts and also through an electromagnet. If the current gets too high, the pull of the electromagnet becomes strong enough to release the iron catch. So it will release the iron catch, so the contact open and stop the current. So this is the function how circuit breaker works. So look again. If the current gets too high, the pull of the electromagnet becomes strong enough to release the iron catch. So the contact open and stops the current. Pressing the reset button closes the contact again. So here is a figure and here is a reset button. Here are the contacts. So when, look here, so normal flow of the current, so the contacts are in touch, but the when flow of the current is too high, contacts broken, and this is how the flow of the current stops. Okay, the next topic that we are going to read is the magnetic relay. A magnetic relay is a switch operated by an electromagnet. With a relay, a small switch with thin wires can be used to turn on the current in a much more powerful circuit. For example, in the vehicles, for example, one with a large electric motor in it. And here is a figure. When the switch S is in the output circuit is closed, a current flows through the electromagnet. This pulls the iron armature towards it. So this is how iron armature towards it, which closes the contact C. So here the contact C is closed. So this is the contact C. This is closed. As a result, a current flows through the motor. So this is how the current flows in the motor, but the relay above is of the normally open type. When the input switch is off, the output circuit is also off. A normally closed relay works the opposite way. When the input switch is off, the output circuit is on. So this is the opposite work. So this is normally closed and this is normally open. So in normally open relay, when the input switch is off, the output circuit is off. But in normally closed relay, work opposite the way. When the input switch is off, the output circuit is on. In practice, most relays are made so that they can be connected either way. With a relay, a small switch can be used to turn on a powerful starter motor. The advantage of using a magnetic relay is that we can use a small current circuit to switch on a large current circuit. For example, in a car, the starter motor needs a very large current, 100 ampere or more, which should be carried in thick wires kept as short as possible. A relay is used so that this large current is switched on by a smaller current in the dashboard switch. Relays are often used in the electronic circuits to control a large current. In car factories, car bodies are welded together by robot machines controlled by computer. The computer uses a small current and a relay to switch on the large currents for the robots. So, relays are used. The next topic that we are going to read is the microphone. Sound waves cause the diaphragm of the microphone to move backward and forward. So sound waves actually cause the diaphragm to move backward and forward. This varies the pressure on the carbon granules between the movable carbon dome attached to the diaphragm and the fixed carbon cup at the back. When the pressure increases, the granules are squeezed together, thus lowering their electrical resistance. A decrease of the pressure has the opposite effect. So the pressure of the sound waves actually squeeze them, and the release of the pressure has the opposite effect. These changes in resistance causes the electric current to vary in the same way that the sound waves varies. So here you can see this is the figure of the speaker. The next thing that we are going to read is the loudspeaker. Varying current from the amplifier at the output of a radio or cassette player pass through a short cylindrical coil. The coil's turns are at right angles to the magnetic field of the magnet, with a central pole and a surrounding ring pole. So this is a figure. This is the ring pole. Thus a force acts on the coil, which makes it move in and out. The paper cone attached to the coil moves with it and set up sound waves in the air around the loudspeaker. This is how loudspeaker works. The next thing that we are going to read is the magnetic storage. Although CDs and DVDs are popular, many people still use magnetic tape for recording sounds and TV pictures. The tape consists of a long, thin plastic strip coated with a layer of the iron oxide or similar material. Magnetically, iron oxide is between the soft and hard. So this is the quality of the iron oxide. Once magnetized, it keeps its magnetism, but is relatively easy to demagnetize also, ready for another recording. The diagram below shows how sound is recorded on tape. The hard drive in a computer also stores data as a pattern of the varying magnetism. In both examples, an electromagnet creates the varying magnetic field needed for the recording. Later, a playback head can read the pattern and produce a varying current. Recording on the magnetic tape. The incoming sound waves are used to vary the current through a tiny electromagnet in the recording head. As the tape moves past the head, a track of the varying magnetism is created along the tape. And this is the picture of the topic. So here is the next topic, computer hard drive. The recording head is at the end of the arm. It contains a tiny electromagnet which is used to create tracks of the varying magnetism on a spinning disc. The disc is made of the aluminum or glass and is coated with a layer of the magnetic material similar to that on the tape. The next topic that we are going to read is the electric bell. So this is an important topic which normally comes in the paper. When the bell push completes the circuit, a current flows through the electromagnet. The soft iron armature is attracted towards the electromagnet and the hammer hits the gong. So this is the hammer, this hits the gong when the circuit is complete. This movement breaks the circuit at point X. So this is the function, so that the current stops flowing and switches off the electromagnet. So this is how the bell stops. The spring pulls the armature back to so that the contact is made and the sequence begins again. The make and break contact screw at X is adjustable to give the best sound. If the gong is removed, the bell becomes a buzzer. So then it will just like make a sound that is buzz. So this is the thing. The next thing that we are going to read is the ding dong doorbell chimes. Figure below shows the circuit of these two tone chimes. When the switch is closed, a current flows in the coil. A magnetic field is set up inside the coil which attracts the soft iron collar fixed to the bobbin. The bobbin moves to the right to strike the right hand metal plate and then makes a sound ding. This produces the ding sound. Most of the kinetic energy of the bobbin is given to the coil spring as the potential energy as it becomes compressed against the side of the magnetic coil. The bobbin stays to the right for as long as charge flows through the coil. But when the current is switched off, the magnetic field collapses. This is now no force pulling the bobbin to the right, so that the potential energy stored in the spring causes the bobbin to move quickly to the left. It then strikes the left hand metal plate and it produces a sound that is dong. So this is how ding dong sound creates. This gadget works because the iron collar becomes an induced magnet and is attracted into the coil. The next thing that we are going to read is the telephone earpiece. The horseshoe type magnet inside the earpiece is formed by placing two soft iron rods on a permanent magnet. Coils are wound round the soft iron rods to make an electromagnet. The permanent magnet ensures that the diaphragm made of the magnetic alloy is in a state of the permanent tension. As the current through the coils varies, the strength of the electromagnet varies and thus the force on the diaphragm varies. The current varies at the same rate as the voice and thus the sound is reproduced. So this is how the earpiece work. So the next thing that we are going to read is the reed switch. A reed switch is a magnetic switch. It has two pieces of the soft iron called the reeds, supported by metal, which has a spring properly. The reeds are enclosed in a glass container which is filled with an inert gas. This gas is used instead of the air because the metal does not react with it and so does not corrode. So another gas should be used instead of the air. When a magnet is brought close to the reed switch, it makes the soft iron reeds become magnet. The opposite poles on the free ends of the reeds attract each other. The magnetic force between them bends the two pieces of the springy metal so that the two reeds touch and close the circuit, allowing the current to flow. When the magnet is taken away, the soft iron reeds lose its magnetism and the tension force in the spring metal pulls the reed apart. So this is how the circuit breaks. This type of the reed switch is used in the burglar alarms when the reed switch is placed in the door frame and magnets are placed in the door and the door frame. So this is how the magnet doors are used. So this was the lecture, students. I hope so this will be much more easier for you to understand now. These are very comprehensive notes as far as your papers are concerned. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.